This section is 3.08 word problems. It's the last section of Unit 3. So when we're looking at a word problem, I think it might be helpful to break it down into some steps so you know you have a place to start. And step one is just read the problem carefully. So make sure you read the problem, maybe reread it if you need to. Step two then will be make sense of the problem. You might want to draw a picture, make a table of values to see a pattern forming, think of a similar and easier example, etc. Just do something that might help you make sense of the problem or think of a scenario. And then identify the unknown. So there's going to be something that we don't know in each of these problems that we will want to find out. This is going to be our variable. And then we get to, pick the variable that we're going to use in order to write the equation, which is the next step. So now we have to set up our equation so that it makes sense to the situation. That's why it's really important to read it, to do those earlier steps, to read it carefully and try to really make sense of the problem. Because now when you're writing your equation, we have to use addition, subtraction, multiplication, division, and parentheses correctly. More than likely, we're not going to have to use all of those in a single equation, but you'll probably have to use at least one of those things. Step 5, solve your equation for the unknown. This will be a review of previous sections. I believe more than likely it'll be all of the sections up to 3.04 that we'll be reviewing when we're solving these equations in these word problems. We will not have equations that we saw in um, sections 305, 6, and 7. And then make sure that your answer makes sense. Check it. You could plug it back into the equation, or if the actual answer doesn't make sense, maybe your equation needs some fixing. So make sure it makes sense as well. Okay, so some key words that can come in handy. The first few examples that we're going to get into actually are not story problems. They are word problems, but they're not going to be stories. They're just going to be um, sentences that are describing an equation, and we're going to write them out. So here, you can always come back to this spot in the video if you'd like, but some different keywords for addition, subtraction, multiplication, division, parentheses, like times the sum of or times the difference of. That means you're multiplying a sum, and a sum is two things being added. So to multiply the sum, you have to use parentheses there. Turnaround words, those are with subtraction. So if something is less than another thing, if A is less than B, then you would write, let me get a different color here. If A is less, you want A less than B, meaning you're taking A away from B. So you'd actually, even though it says A less B, we're going to subtract it in the reverse order. So B minus A. Or something is subtracted from another thing. So if we want 7 subtracted from 10, we actually write the 10 first and then minus 7. So that can be tricky. And then some equal sign words. Is the same as, equals, is equal to. Okay. All right, let's take a look at some of these. 4 times a number increased by 7 is 3. All right, so number 4, times, time sign, a number that could be, that's of some unknown thing. It's just a number, so we can use a variable. And you can be creative if you want here. I'll just use X for this one. Increased by 7, that's an addition word. Increasing is an addition. By 7 is, we were just looking at that one, is equals 3. Now this is just really spaced out right now. I'll probably write it a little tidier off to the side. 4 times x is just 4x plus 7 equals 3. And we actually have a two-step equation now to solve. So we can undo the plus. Remember, we take care of addition before multiplication. And those cancel on the left side because those are inverses. So we're left with 4x on the left side. And 3 minus 7, that equals -4. And we do have multiplication there. That's 4 times x here. So the inverse of that is dividing by 4, and we have to do it to both sides. That cancels out. The inverses cancel on the left side. And we just have to figure out what is -4 divided by 4. So it's going to be x equals, well, -4 divided by 4 is -1. And that is our solution. Okay, 5 times the sum of a number and 6 is the same as 45. Okay, so we talked about this phrase whenever you're timesing the sum of something. If you recall, that's a parentheses situation. So we've got 5 being multiplied to something in parentheses, and it's a sum, so it's going to be two things being added. The things that we're adding are a number and 6. So 6 and then a number that can be a variable. This time I'll use n. Is the same as, that's an equal sign, 45. Okay. And I'll condense that into a little tighter equation here. N plus 6 equals 45. And this could be a two-step equation or a three-step equation, depending on how you do it. Because that 5 is being multiplied on the outside of parentheses, you could divide by 5 first and go from there. But I think I'm going to show the distributing move. So if you distribute 5 first, that's also fine. So if you do that, that's going to be 5 times n is 5n. 5 times 6 is 30. And that is still equal to 45. We didn't do anything over there. And now it's a two-step equation. Just like that last one, we take care of the addition first. The inverse of addition is subtraction. And since they're inverses, they cancel. And we're left with 5n equals 45 minus 30 is 15. And that is multiplication, right? 5 times n there. So the inverse of multiplication is division. And the inverses undo each other there. And then we just get n equals, well, 15 divided by 5 is 3. All right, and one more to take a look at here. Okay. Yeah, all right. So 4 less than the product. So 4 is less than this whole thing. So that means, or we want 4 less than this whole product. So that is a turnaround word. So that's kind of tricky. So we're going to turn this around where the product is going to be before the less than 4. So I know I'm going to be subtracting 4. So now this product is a multiplication of two things that's happening before that. And it's of a number and 7. So, like A, let's say, the letter A we'll use for the number. And typically, so you could write A times 7. Typically, we put the number first, 7 times A. But it really doesn't make a huge difference. And that equals, all right? That's pretty straightforward. Equals 8 more than that number. And again, okay, so more than in this case is addition. Again, it doesn't matter which order you write them. You could write 8 plus the number, which that number we're reusing, so we have to use A again. So 8 plus A or A plus 8. I think I'm going to do A plus 8. Okay, so then 7 times a, just to rewrite the way it looks, 7a minus 4 equals a plus 8. And if you want to, that's a 1a in front, or a coefficient of 1 on that a. All right. Now, this is a review of, I believe it was section 3.04, because you might notice we have variables on both sides. And, well, even before that, you would check, okay, can we simplify? Can we combine like terms on the left side or the right side? Can we distribute on the left side or the right side? Can we do any of those things? And you can't here. So here we want to cancel out either the 7a on the left side or the 1a on the right side. Since each of them are positive, the way we would cancel them is through subtraction. And I think it'll be easier if we subtract 1a, because that'll cancel it on the right side. And if I subtract 1a from the 7a, I'll get a positive 6, which is a little nicer. If I subtracted 7, you'd end up getting a negative number, which you could do just maybe a little more. It's nice to avoid negatives if you can, I suppose. So that's 6a minus 4 equals 8. Let's make that bigger. Okay, so now it's a two-step equation. So undo the minus 4 by adding 4. That's the inverse. And you gotta do it to both sides. So since it's inverses, we know those cancel. The 6a is still here, and 8 plus 4 is 12. All right, 6 times a, the inverse is division, right? So divide both sides by 6. Inverses cancel. And a equals 12 divided by 6, which is 2. So let's write and solve the equations that we get from this. Billy cycles 6 kilometers during each trip to work. How many trips will Billy have to make to cycle a total of 12 kilometers? Okay. And you might be able to do that mentally, but what I would like us to practice is, can we write an equation for this? Because honestly, yeah, I can do that mentally. 6 kilometers during each trip, and there's 12 kilometers. Well, I know 2 6s make 12, so it's going to be. I'm pretty sure the answer is going to be 2. So if you want to draw a picture to make sense of it, though, he's got home, he's got work, whatever path he's taking. Let's just assume it's a straight path, I suppose. It's a 6 kilometer distance. Okay. So every trip he goes is 6. If it was a bigger number, we might have to think about it a little more than 12, I mean. And maybe, so every time is 6. And I said every time. So if you do it a bunch of times, you would multiply 6 by however many trips you're making it. Okay. And that is the unknown that we're trying to figure out, right? How many trips? That's the question. How many trips? So first, let's let let's let t, lowercase t, be the number of trips. Okay. And then to find out the total distance you go, you would take the number of trips times however, the distance that we go every time. So it's 6 times the number of trips, and that'll be our total. Now in this case, we know our total is 12. So 6 times t equals 12, or just 6t equals 12. And then to solve that, and then in this case, that is part of the answer. Okay, that is part of the answer, just writing the equation. That's part of what I want you to do. Okay, but then solving it, we could divide, right? Because that's multiplication, so divide each side by 6. And those 6's undo, and 12 divided by 6 is equal to 2, which is what I was expecting. And this would be technically labeled as 2 trips. So 2 trips to work, he'll get his 12 kilometers.